Hello my friends, and welcome back to Sky Creative Channel. Today we're taking you inside the factories of tomorrow, where cutting-edge machining technology is revolutionizing how the world's largest corporations create everything. Let's dive in. What you're witnessing here is nothing short of engineering brilliance, the Gleason Agilis 180th, a machine that's redefining efficiency in gear manufacturing. This isn't just any ordinary machine tool, it's a 4-in-1 powerhouse that combines turning, hobbing, chamfering, and deburring operations in a single setup. Let's break down what makes this machine extraordinary. First, the turning operation. Watch as the workpiece rotates at precisely controlled speeds, while the cutting tool shapes the gear blank to exact specifications. The machine's rigid construction ensures vibration-free operation, critical for achieving the tight tolerances demanded in automotive and aerospace applications. Now we transition seamlessly into the hobbing process. This is where the magic happens. The hob cutter, resembling a threaded gear itself, rotates in perfect synchronization with the workpiece to cut the gear teeth. The Agilis 180th's advanced CNC system calculates thousands of positioning movements per second, ensuring each tooth is cut with micron-level accuracy. Notice the chamfering operation next. Those sharp edges are being precisely beveled to prevent stress concentrations and improve gear meshing characteristics. Finally, the deburring process removes any remaining sharp edges or metal particles, delivering a finished product ready for assembly. What sets the Agilis 180th apart is its ability to complete what traditionally required 4 separate machines and multiple setups in one continuous operation. This dramatically reduces production time, eliminates positioning errors between operations, and significantly improves surface finish quality. Major automotive manufacturers rely on machines like this to produce the transmission gears that keep millions of vehicles running smoothly every day. Here we're observing precision, turning at its finest with the MT-Cut T30MC, equipped with VDI-40 tooling system, working on 42 CRM04 steel, a material choice that tells us we're looking at high-performance components, likely destined for automotive or heavy machinery applications. NTHE hydraulic coupling system you're seeing is a game-changer in modern turning operations. Unlike traditional mechanical chucking systems, this hydraulic setup provides uniform, adjustable clamping pressure around the entire workpiece circumference. Notice how the 55 mm diameter by 105 mm long workpiece is held with incredible rigidity. This prevents the vibration and deflection that can ruin surface finish and dimensional accuracy. Watch the cutting tool engagement. That's a carbide insert, specifically designed for the unique properties of 42 CRM04 steel. This alloy steel, containing chromium and molybdenum, requires specific cutting parameters to achieve optimal results. The machine's sophisticated control system automatically adjusts spindle speed, feed rate, and cutting depth based on real-time cutting force feedback. NTHE coolant flood system is working overtime here, not just for cooling, but also for chip evacuation. Proper chip removal is crucial when machining tough alloys like 42 CRM04. Any chip recutting can damage the surface finish or even break the cutting tool. What's particularly impressive about the T30MC is its thermal stability. The machine's design incorporates thermal compensation algorithms that adjust for heat expansion during the machining process, maintaining dimensional accuracy even during extended production runs. This level of precision and reliability is why companies like Caterpillar and John Deere trust similar technology for manufacturing their heavy equipment components. Prepare to be amazed by raw machining power. This Waldrich plano miller, equipped with a massive 110 kilowatt spindle motor, is rough-face milling a plate measuring 2,000 by 1,200 millimeters. That's over 6 feet by 4 feet of solid steel, being shaped with incredible precision. NTHE sheer scale of this operation is breathtaking. Face milling operations like this are typically used in heavy industries. Think shipbuilding, power generation, and large-scale construction equipment manufacturing. The material removal rate you're seeing here would take conventional smaller machines days to accomplish. Notice the massive face mill cutter. Those aren't just any cutting inserts. Each one is precisely positioned and secured to handle the enormous cutting forces generated during this operation. The 110 kilowatt spindle provides the torque necessary to maintain consistent cutting speeds, even under these extreme loads. NTHE Machine's gantry design is specifically engineered for this type of large-scale work. Those massive linear guides and ball screws can position this multi-ton spindle assembly with positioning accuracy measured in hundredths of a millimeter, despite the enormous forces involved. And watch the chip formation. Those long, continuous chips indicate optimal cutting parameters. Poor chip control in operations this large can be dangerous and costly. The sophisticated coolant delivery system not only manages heat, but also helps direct chips away from the cutting zone. Companies like General Electric use similar technology for manufacturing turbine housings and generator frames. This level of precision on this scale is what enables the massive infrastructure projects that power our modern world. Welcome to the future of mold and die manufacturing. This Hermel C400 configured for 5-axis machining is creating a sailing boat component from 1.4404 stainless steel. And here's where it gets really interesting. Starting from an additively manufactured blank using MPA technology, and 5-axis machining represents the pinnacle of CNC technology. Unlike traditional 3-axis machines that can only move the cutting tool in X, Y, and Z directions, this machine can also rotate the workpiece around 2 additional axes. This means complex curved surfaces can be machined in a single setup without repositioning. NTHE additive manufacturing preform we're starting with is revolutionary. Instead of cutting away 80 to 90% of the raw material as waste, the MPA metal powder application technology has already deposited material very close to the final shape. This hybrid approach, additive manufacturing followed by precision subtractive machining, represents the cutting edge of efficient manufacturing. Watch how smoothly the machine transitions between cutting angles. The Hermel's advanced path planning software calculates the optimal tool orientation for every point along the cutting path, ensuring consistent surface finish while avoiding collisions between the tool holder and the complex workpiece geometry. NTHE 1.4404 stainless steel choice isn't coincidental. This marine-grade material will resist corrosion in the harsh sailing environment. The precision achievable with this 5-axis setup ensures perfect fit and finish for what's likely a high-performance racing yacht component. This technology is transforming industries from aerospace to medical devices, where complex geometries and tight tolerances are the norm rather than the exception. This is absolutely fascinating. We're watching a Hermel C400 machine a detailed human skull using SolidCAM programming software. This demonstration perfectly showcases the incredible capability of modern 5-axis CNC technology to handle the most complex geometries imaginable. NTHE Skull represents one of the most challenging machining projects possible. It contains virtually every type of surface complexity: deep cavities, undercuts, thin walls, and intricate details like eye sockets and nasal passages. Traditional machining methods would require dozens of setups and specialized fixtures, but 5-axis technology tackles it all in one continuous operation. SolidCAM's advanced CAM programming is the real hero behind this operation. The software analyzes the 3D skull model and automatically generates thousands of tool paths while considering factors like tool accessibility, surface finish requirements, and collision avoidance. Notice how the cutting tool approaches from constantly changing angles. This is the software optimizing every movement for efficiency and quality. NTHE constant tool orientation changes you're observing serve multiple purposes. By tilting the tool relative to the surface being cut, the system can use longer, more rigid cutting tools while maintaining optimal cutting geometry. This reduces tool deflection and improves surface finish quality dramatically. You watch the transition between rough and finish machining strategies. Initially, the machine removes large amounts of material quickly using aggressive cutting parameters. As we progress to finishing operations, the feed rates slow down, and the tool paths become much denser to achieve the smooth surface finish you see developing. This type of complex machining capability is crucial in industries like medical device manufacturing, where patient-specific implants and surgical guides are becoming increasingly common. The same 5-axis technology creating this demonstration skull is also producing life-saving medical devices in hospitals around the world. Here's precision turning at its finest, the VDF Boehringer VDF 250T working on a lathe shaft, a critical component in transmission systems that requires absolute precision to function properly in high-performance applications. NLAY shafts are among the most challenging turning projects because they combine multiple diameters, precise spacing between features, and extremely tight tolerances. The shaft you're seeing machined will likely end up in a heavy-duty transmission where even microscopic imperfections could lead to premature wear or catastrophic failure. NT-HE VDF 250T's thermal stability is crucial for this type of work. During extended machining cycles like this, heat generation from cutting can cause the machine structure to expand, potentially affecting accuracy. The Boehringer's sophisticated thermal management system includes coolant circulation through the machine structure itself, maintaining consistent accuracy throughout the entire machining cycle. Notice the tool change sequences. Each diameter and feature requires specific cutting tools optimized for that particular operation. The machine's tool magazine holds dozens of precisely preset tools, each one automatically positioned to continue the machining sequence without human intervention. NT-HE's surface finish you're observing is critical for lathe shaft applications. These surfaces will mate with bearings and gears under high loads and speeds. The VDF 250T's rigid construction and advanced vibration damping systems ensure the surface finish meets the stringent requirements for modern transmission applications. Companies like ZF Friedrichshafen and Eaton rely on this level of turning precision to manufacture the transmission components that keep everything from sports cars to 18-wheelers moving efficiently down the highway. What we're witnessing here is the remarkable precision of a Haas CNC lathe, creating what appears to be a detailed human hand, a perfect demonstration of how modern CNC turning technology can achieve artistic levels of detail while maintaining manufacturing precision. This project showcases the incredible versatility of contemporary CNC lathes. While these machines are typically associated with cylindrical parts like shafts and sleeves, advanced programming techniques allow them to create complex sculptural forms through strategic use of live tooling and sophisticated toolpath programming. NT-HE Haas control system is orchestrating thousands of precise movements to create the intricate details you're seeing. Each finger, each knuckle line, every contour is the result of carefully calculated toolpaths that push the boundaries of what's possible on a turning center. Notice the constant surface speed control. As the diameter of the part changes from fingertips to palm area, the spindle speed automatically adjusts to maintain optimal cutting conditions. This ensures consistent surface finish across the entire complex geometry. NT-HE cutting tools being used are likely ball-end mills and specialized forming tools, each one carefully selected for specific portions of the hand geometry. The machine's tool changer is working continuously, switching between dozens of different tools as the program progresses through its sequence. This type of programming expertise and machine capability represents the future of manufacturing, where the line between industrial production and artistic creation continues to blur. The same technology creating this artistic demonstration is also producing medical prosthetics and specialized components that require this level of geometric complexity. Here's something truly special. One CNC's research department demonstrating their advanced CAM software capabilities by machining a complete soccer ball from solid material. This isn't just showing off. It's a masterclass in complex surface machining and advanced programming techniques. NTHE soccer ball geometry presents unique challenges that highlight the sophistication of modern CAM software. Those traditional black and white, pentagonal, and hexagonal panels require precise three-dimensional surface transitions, exactly the type of complex geometry found in aerospace and automotive components. And watch how the cutting tool follows the curved panel boundaries. One CNC's advanced surface machining algorithms are calculating tool paths that maintain consistent scallop height across the entire curved surface. This ensures uniform surface finish while maximizing material removal efficiency. NTHE, seamless transitions between different panel geometries, demonstrate the software's ability to handle multiple surface patches with varying orientations. In real-world applications, this same capability allows manufacturers to machine complex turbine blades, automotive body panels, and medical implants with confidence. Notice the constant chip load management. Despite the continuously changing surface angles, the cutting conditions remain optimized throughout the operation. This is achieved through sophisticated feed rate modulation that considers factors like tool engagement angle, surface curvature, and material removal requirements. NTHE precision required to create the sharp lines between panels while maintaining the overall spherical form showcases why advanced CAM software like One CNC is trusted by major manufacturers worldwide. This technology is enabling the production of increasingly complex components that were simply impossible to manufacture economically just a decade ago. Automotive design meets cutting-edge manufacturing technology. This solid CAM eye machining demonstration with Sim5X simulation is showing us how modern car models progress from digital design to physical prototype using advanced 5-axis milling technology. Not NTHE eye machining technology you're witnessing revolutionizes traditional machining approaches. Instead of conventional straight-line tool paths, eye machining uses spiral and curved movements that maintain constant tool engagement. This results in dramatically improved tool life and significantly faster cycle times, critical advantages in today's competitive automotive industry. SolidCAM's Sim5X simulation capability is running in real time, predicting and preventing potential collisions before they occur. This virtual verification process has transformed manufacturing efficiency by eliminating the costly trial and error approaches that plagued earlier generations of complex part manufacturing. Watch the smooth surface development as the car's aerodynamic curves take shape. The 5-axis capability allows the cutting tool to approach each surface at the optimal angle, eliminating the witness lines and surface imperfections that would result from 3-axis machining approaches. NTHE material removal strategy, visible here, is particularly sophisticated. Notice how the rough machining removes maximum material while leaving uniform stock for the finishing operations. This two-stage approach optimizes both productivity and surface quality. Major automotive manufacturers like BMW and Mercedes-Benz rely on exactly this type of technology for creating prototype parts and production tooling. The ability to go directly from CAD model to finished part in hours rather than weeks has revolutionized automotive development cycles and enabled the rapid innovation we see in today's vehicle market. We're concluding with something truly revolutionary. Sandvik Corriman's Invo milling system, demonstrating flexible gear milling technology that's changing how manufacturers approach gear production worldwide. And traditional gear cutting methods require dedicated machines and specialized tooling for each gear specification. Invo milling transforms any standard machining center into a capable gear manufacturer using innovative cutting strategies and tool geometries. Watch the cutting action carefully. The tool is following a complex interpolation path that generates the precise involute gear tooth profile through coordinated machine movements. This process eliminates the need for expensive gear hobbing machines for smaller production runs or prototype work. NTHE flexibility advantage is enormous. The same machine setup can produce spur gears, helical gears, and even internal ring gears simply by changing the programming parameters. For companies producing custom or low-volume gear applications, this represents a massive cost advantage over traditional gear manufacturing approaches. And Sandvik's cutting tool technology enables this process through specialized insert geometries and coatings optimized for the unique cutting forces encountered during gear interpolation milling. The result is gear quality that rivals traditional hobbing methods while offering unprecedented manufacturing flexibility.